For more information, please visit SGMAK Associates website.
This module is about how to convert PDF to CDF and some use of this conversion. We talk about probability density function when we deal with a continuous random variable. Area under a density function between two values a and b greater than a, represents the probability of the event that the random variable takes value between a and b. Every distribution has unique PDF. If fx is the PDF of a random variable x, then the CDF, typically represented by f, capital F of k, is probability x takes value less equal k, or is equals to the area under the density function between the lower bound and that specific value k. A large number of problems may be reduced to estimating what's the probability the random variable takes value between a and b, which can be written in terms of the CDF as f of b minus f of a. This is the most important use of CDF you'll find as you solve different problems. Let's look at a few examples. Let's talk about a uniform distribution with parameters a and b, where a is the minimum value and b is the maximum value. It has a PDF 1 over b minus a, x between a and b and 0 otherwise, and the corresponding CDF f of k is given by f of k's probability the random variable takes value between a and k. A is the lower bound, k is a specific value, is given by k minus a divided by b minus a. F of a is 0 and f of b is 1, which is the probability of the CDF, which we talked about earlier also. Probability the random variable takes value between two arbitrary values L and M is given by M minus L divided by B minus A. Let's take a look at an example. The problem statement says the opening price of a stock is uniformly distributed on the interval 60 and 72. It can take any values between 60 and 72. All values are equally likely. What is the probability that on any day the opening price is less than 65 or between 66 and 70? The opening price of a stock is a example is treated as the uniformly distributed random variable. So we can solve both parts by using the CDF for the uniform distribution with parameters 60 and 72 is given by f of k is k minus 60 divided by 72 minus 60. So probability x less equals 65 is given by, if you put k equals 65, 0.416, and probability x takes value between 66 and 70 is given by 70 minus 66 divided by 72 minus 60, which is 0.33. Let's look at another example of a different distribution. A box of candy contains 18 bars. The time between demand for these candy bars is exponentially distributed with a mean of 12 minutes. So on average, every 12 minutes, there's a demand for one candy bar. What is the probability that a box of candy that you opened at 9 a.m. will be empty by noon? So on a 3-hour time span, 18 or more candy bar will be demanded, where the average demand is 5 per hour. The problem has to be solved by utilizing the relationship between an exponential distribution and a Poisson distribution. It's a very important relationship. There are a lot of examples where you have to utilize this relationship. The interval time of 12 minutes, interval time of a demand, every 12 minutes there is a one unit of item, a candy bar is demanded. So we can view that as a demand for 5 candy bars on average in an hour. We are looking at a planning period. A period of interest is 3 hours. So you can model demand for candy bars in a 3-hour period using a Poisson distribution with a mean of 15 units. Now what we are interested in is to find out what's the probability that 18 units or more will be demanded in a 3-hour period. So we can write that as probability demand is 18 or more, where the demand follows the Poisson distribution with a mean of 15 units. Now, a greater than type probability, you can always will be converting into less than type, complement of a less than type, so that you can use the typical CDF lookup table. So in this case, we'll write probability demand greater or equal 18 is given by equals to 1 minus probability demand is less equal 17 units. In terms of CDF, which is 1 minus f of 17 using a Poisson distribution with a mean 15. So using statistical function in Excel, we can write that as equal 1 minus Poisson distribution, parameter 17, 15, true. And that gives a value of 0.251. We use true when you use the CDF. In this example, the problem statement describes a continuous distribution, exponential, because you talk about time between demands following exponential distribution. But problem is solved using a Poisson distribution, which is a discrete probability distribution. So the probability a box of candy will be empty in a 3-hour period is 0.25. Moving on, note that for a discrete distribution, such as Poisson, probability x greater equal 18 is equal 1 minus probability x less equal 17, since the random variable takes on all integer values. So had it been a continuous distribution, we would have used probability x greater equal 16 equal 1 minus probability x less equal 18. Probability x greater equal 18 we would have written as 1 minus probability x less equal 18. Because for a continuous distribution, probability, the random variable takes a specific value, all is equals 0. For a discrete distribution, we cannot say that because the variable may have a value, may have a probability attached to a specific value, may or may not have. So you cannot make that blanket statement dealing with a discrete distribution. Let's look at another example. The life of a particular dry cell battery is normally distributed with mean of 600 days and standard deviation of 60 days. What fraction of these batteries would be expected to survive beyond 680 days? What fraction would be expected to fail before 550 days? So you are dealing with the life of a battery, and the distribution we are using is normal distribution with a mean of 600 and a standard deviation of 60 days. Let's look at the solution. The random variable life of the cell follows normal 600, 60 distribution. Probability, the random variable x greater than 680, we can solve either using normal distribution or standard normal distribution using statistical function provided by Excel. The first function can be used for an arbitrary normal distribution, where the second function is used in case of a standard normal distribution. A standard normal distribution is a normal distribution with a mean 0 and standard deviation 1. So we can solve the problem in two ways. Using statistical function from Excel, we can write it as equal to 1 minus norm dot distribution with parameters 680, 600, 60, true, and that number is 0.092, about 9.2%. Or you can use the standard normal distribution. You can write that as 1 minus norm dot s dot dist with parameters 1.33 and true, and you get the same value. Where z score for that value x equals 680 equals 680 minus 600 divided by 60, which is 1.33. You always subtract the mean and divide by the standard deviation to convert an arbitrary x value to a corresponding z value. Similarly, if you want to find out what's the probability x less than 550, so which is we write in terms of CDF F550. Now we can write that as a norm distribution 550, 600, 60 true, or norm dot s dot distribution with parameter minus 0.833, true, and the value is 0.202 or about 2%. The z-score for x equal to 550 is given by 550 minus 600 divided by 60, which is minus 0.833. Remember, the general rule for solving normal distribution problem is as follows. Probability x takes values between a and b is given by norm.dist with parameters b, mu, sigma, true, minus norm.dist with parameters a, mu, sigma, true, or we can solve using in terms of standard normal distribution where the parameters changes to b minus mu over sigma and a minus mu over sigma. The objective of this presentation is to communicate the importance of using the CDF in problem solving. Every distribution has unique PDF and an unique CDF. The goal is to take the PDF and convert into CDF. In problem solving, CDF is used most often. We find the CDF by finding out the area under the PDF between the appropriate limits. For most commonly used distributions, CDF is available as lookup table at the end of textbooks. Be familiar with the use of statistical function offered by the Excel software. Let us know if you have.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.